Hey everyone, my name's Tom and I'm here with this engine. This is my engine for Mac. This is a 1987 Carrera 3.2 engine and I haven't done much with it. Even though I picked it up, I guess it's like a year and a half ago. This was the trip I took to Colorado with Alex. We camped along the way, picked up a whole truckload of parts, and it's been sitting. All I've really done to this engine is replace the exhaust. I traded this stock exhaust for this aftermarket stainless one. And I'm hopefully going to get it started today on the test stand. And every engine has a different story, so we'll see what it needs, what it sounds like with the new exhaust. Let's try to get it started. Let me show you. First problem I ran into is here with the flywheel. So this is from an 87 G50 car, and I've already removed the pressure plate because I just couldn't get the starter that I have to work with that pressure plate and the ring gear and so forth. Plus this is a new product for me, so I'm still adjusting the dimensions. So I'm not able to use the G50 flywheel in the 915 anyways, so I'm going to be swapping out the flywheel for the correct one that will mate up with my 915. Shane did tell me when I bought this engine and parts that this was a brand new flywheel. It's a lightweight flywheel by Patrick Motorsports, like stage 1 package or something. And these are the bolts. They're special bolts that require a unique tool. The tool looks like this. It's really like a 12 point, or I think it's called triple square, 12 millimeter. So it's a unique socket that goes in. It fits really well into those bolts. So this is not the ring gear for the starter. This is how these sensors determine how fast the engine's turning and what position the crankshaft is in. So that is not where the starter touches. I don't want to use an impact wrench on this because it's pretty easy to strip this socket, I think, and it's not a super high quality socket, so better to just use hand tools, I think. I just thought of something before I pull this off. I'm not sure it's going to come off inside this ring anyways, but I think I should put it in top dead center for number 1 so I can make sure that the orientation of the flywheel sensor is in the right place when I put the new flywheel on. They should be the same, but it's better to know where you are before you take it apart. If I just pop off the distributor cap, we can make sure it's pointing to number 1. You can see the mark on the fan housing, and then there's 2 marks there on the crank pulley. So let's make sure we line it up with the one that goes to number 1. I think that's number 1 right there. That's the bigger of the 2 notches. That pulley's a little rusty. Mostly pointing up. It's a little bit to the right of up, but that's where it is right now on this flywheel. So I'm hoping the 915 flywheel has it in the same place. So I'm just going to reach underneath here, reach up here, and just, oh, yep, see it's coming loose. So it is not going to come through this ring, but that's okay. I have to change this ring to the 915 adapter. The flywheel is pinned right here, so it only really goes on one way. So the crankshaft seal here has really nothing to do with the flywheel. Also, the end play of the crankshaft is not like the earlier 356 engines. It's not adjustable. It's determined by the bearings inside the engine. So really, it's a pretty simple matter of putting the flywheel back on. I'm just going to degrease a little bit of this. Doesn't look like it's leaking. This is just normal sort of dust, I think. That's a little bit better. At least now I can tell if the main seal's leaking or the flywheel seal's leaking. At least I'll be able to see the new versus the old. Here's the two flywheels side by side. This is the 915. This is the G50. And the diameter of this outer ring is the same because I put one on top of the other. This tooth pattern is identical. The same number of teeth, everything like that's the same. And I've put the dowel position at 12 o'clock just to see where it falls on. This side has the screw which measures where the crank position is. So these are roughly in the same place. If this is 12 o'clock, this is about 11 o'clock. And if you're curious about the weights on these, I'll do my best to measure the weights here. This one is, Patrick Motorsports, like I said, 930-102-003-03, lightweight. So it looks like this has a lot more material removed than this one. Plus it has these windows in the outer perimeter, which really helps in the inertia equation. The other difference is this is like a, I think 220 millimeter clutch or 225. It's a 9-inch diameter. The clutch on this one is 9.5. Yeah, probably about 9.5, maybe a little bit bigger. Just by picking them up, I can't really tell which one's lighter. They're pretty close, to be honest. But I did put them on my postal scale, which is not the most accurate. But I have the Patrick Motorsports at 8 pounds, 2.2 ounces. And the 915, the factory Porsche one, is 9 pounds, 12 ounces. So you're looking at a full 1.5 pounds roughly difference between the Patrick Motorsports and the original 915. Now I don't know what the original Porsche G50 flywheel would weigh. I don't have that one, but I suspect it would be a lot more than this one. The other lesson that I learned, you guys, on the 356 is that when you put a new pressure plate on a flywheel, this is a used flywheel, it is good to balance the two. And I had a pretty big problem on my 356 with the pressure plate not being centered in the flywheel, and it caused a lot of vibration. This flywheel has been balanced before. It has some drill marks on there, but it's not matched with the pressure plate that I have. So for today, I'm gonna go ahead and install this. They're pretty easy to take on and off, but before I put this in the car, which is gonna be a little while, I will take this and have it balanced with my pressure plate. Just one final clean here. I can't put a lot of torque on these right now because the way the engine's supported on just the jack and the front cross member. I'm going to go ahead and put the adapter on and then make sure that I can stabilize the engine, and then we'll go ahead and torque these down. This is for the 915, so this should work okay. Now the one thing I just noticed right away, these studs are for the G50. They are way too long, so I'm gonna have to get some spacers so I can at least tighten this down. So this spacing here on the sensor is pretty important. But there is some clearance. It's probably less than 1 millimeter, 0.5 millimeter or something. I can measure that later, but I just want to make sure I'm not grinding or damaging the sensor. This should work though. Now, come to find out, with all this extra stud length and stuff, I am not able to sneak this pressure plate in. So unfortunately, that means I gotta disassemble some of the stand again. But I was just unsafe doing it before. I didn't want to knock the engine over. Give me a few minutes and I will just get that back on there. This is the G50 pressure plate, also aluminum, by Patrick Motorsports or Kennedy Engineering Products. This is the Sachs aluminum lightweight factory flywheel. The difference in weight is pretty significant. So this one is 19 pounds and this one's 12 pounds, including the ring gear. I had to use the ring gear on the other flywheel, but that is a total with the 915, 21 pounds, 12 ounces. The lightweight Patrick stuff for G50 is 27 pounds, 2 ounces. So almost 7 pounds difference with the G50 to the 915. So you get, you know, with the 915, lighter transaxle, quicker revving, another benefit for staying with the 915, guys. All right, I'm back. I've got the flywheel on. So that's the flywheel, pressure plate, everything's torqued up good enough to run on the test stand. I really should have changed the flywheel when I had the engine on the pallet, but I just didn't have the right components at the time. So I've collected the parts. Now it's up in the air, ready to crank it. This is Valvoline VR1 2050 for high zinc, good for these engines. So let's just dump this in. Now this tank has been cleaned professionally, but they discovered the bottom was leaking right where it feeds into the thermostat. So I silver soldered the fitting back to the bottom and checked it. It should not leak, but this will tell us. This is about 8 quarts. I've pressurized the fuel system before, and the only problem was a leak on this hose right here. This is the factory hose that comes right off the filter. The filter is normally mounted on the firewall or the sidewall of the car. We just cut the ferrule off and just cut a different part of the hose and re-clamped it there. So that hose will get replaced with the factory style hose. But for now, all the fuel leaks are fixed. Some of the emission stuff back here has been plugged up just so we can run it on the test stand. I think all the vacuum leaks are fixed. We can check for that later. This is a big one here plugged up. That hose is just temporarily removed. So I think what I want to try first, this has been sitting so long, I want to just build some oil pressure until the oil pressure light goes out, and then we can fire up the DME. I'm using the FTech 9 diagnostic DME for 911. This thing has been really handy in troubleshooting Benji's car, so I think it's going to come in handy here too. It allows you to check all the sensor outputs. I'm going to connect my laptop in a minute, and I'm also using their DME relay with LEDs, and it tells you exactly what power is going where, like is the ignition on, fuel injection power, fuel pump, control for the fuel pump. Super helpful diagnostic tools. So keep the ignition off. There it goes. Now that's off. Okay, here we go. First time. It's been sitting for a number of years. Let's see if it'll start. Almost. Just getting a lot of popping out the exhaust, which I think is unburnt fuel. Just smells like gas in here. It's really popping. So I did put the gauge on the pressure rail or the fuel injector rail. The DME does not read the fuel pressure directly. So I got this mechanical gauge here. Right about 2 bars. Getting a fair amount of white smoke out of the back too. It seems that the fuel pressure is okay, and I've been letting it run and checking some things on the computer. So the FTech 9 software allows you to track things that are related to the sensors. And so I'm gonna start it up again, show you guys what it's doing. It's having a hard time establishing the engine RPM. Let me show you. So this RPM is all over the place. Sometimes it thinks it's 300, sometimes it thinks it's 2000. So this is showing me all kinds of the sensors with regard to both of the crank position sensors. So I think this one here that has many teeth on it, the one that's closer to me, this one seems to be picking up a good signal, but this one is not. So I'm gonna go ahead and double check the position between the sensors. There's supposed to be a 0.8 millimeter gap between the flywheel and the actual sensor itself. Now 0.8 millimeters happens to be the same as my welding wire, so I'm just going to use that to check the clearance here. I cannot get the 30 thousandths wire or 0.8 millimeter wire on the outer sensor. The inner sensor, I'm going to have to turn the engine until that little feature on the flywheel is right below the sensors. Okay, this side I can get the wire in there, but it feels a little tight actually. It's not a slip fit, so I'm going to loosen the sensors and see if we can't get those adjusted a little bit better. So I removed the whole bracket, and this is what I found. This sensor has been ground down by something else in the past, because I know for a fact when I put this flywheel on, it wasn't touching. So this one is damaged. This is the one that I thought wasn't working correctly. So I'm going to adjust it, but I have a feeling this is no good. I think this needs to be replaced. That could be the reason why it's running so rough. So basically, I'm just gonna lay this wire in between the sensors and the pickup. And then that is going to establish the distance. And I'm gonna do that simultaneously because it's just one bracket for both. But luckily there's enough access here where I can just get that centered over the sensor. The wire is in there and it slides up and down. So that's the kind of tension that there is. It's like a feeler gauge. You just want slight drag. Got a much smoother idle now. Now I'm pretty consistent at 1100, which is pretty normal for the warm-up. This is the chart for the RPM on this axis. This is the flywheel teeth. Every time it counts a tooth, it goes up and then it resets. It goes up and then it resets. So this is looking correct. This line here is counting the number of teeth. 130 teeth every time it goes around. Sometimes it misses one, so you see a little dip. But this is all very normal right here. And the engine's running so much better. Yeah. Just watch the RPM go up. Now it sounds great. This is the O2 sensor, and it's showing it tracking between rich and lean. You can see here low is lean, high is rich, and this all looks very normal as compared to the 911 Cabriolet, the 1989, this is what I had to do to get it to pass smog. And this engine's doing it very well. You can see that the sensor for the NBO2 is alternating between 0 and about 0.7 volts. When it's 0.7, it's rich. When it's 0.1, it's lean. So this is all tracking very well. Now the RPM is settling down too. If we go to this chart, we're seeing the cylinder head temperature going up. Now it's at 180. That's pretty normal. The only thing that's a little bit different is the idle control valve is almost maxed out at 92.5. That can be improved a little bit. That's just an adjustment. So here you see it going between rich and lean. It's all very normal. And the idle is pretty steady right now. It sounds really good. This throwout bearing is allowed to float, so that's why it looks a little wobbly, but that's just because it's not centered in its transmission. So that'll get better when we put it all together. So what do you guys think of the sound? It's pretty throaty. This diameter here on the exhaust is, let me measure, it's pretty big. Yeah, it's a 3-inch exhaust. So it has that deep sound to it, but when the revs come up, it does sound, it sounds pretty good. Little loud for my taste, but you guys let me know what you think. You might think this is the Billy Boat exhaust. It's real similar to Billy Boat, but it's actually, I think it's GNL or GHL. I get them confused all the time. No longer in business, but it's a good foundation. I will likely do something different on my car. I would rather have a center exit, but you let me know what you think. If you like the sound, maybe it's hard to hear it on the video, but for now, any sound is good, right? So that's all I have time for tonight, guys. It's a runner. Got it running pretty smooth, and I've checked all the different sensors. Idle control valve could use to be adjusted. AFM is only reading 1 volt, which is a little bit low. It may need to be adjusted. The O2 sensor is working. The throttle switch is working. The crankshaft sensors are now working, and it's running pretty well. At least it sounds pretty healthy. I'm going to be doing a lot more checks on this engine before it goes in the car. Also do some preventative stuff, like change the fuel lines, probably clean the fuel injectors. I may take the whole intake off and change the intake seals between the runners and the heads. Those are sort of a known weak spot on these engines. They tend to suck the gaskets in and develop a vacuum leak. I will also put the vacuum smoke tester in here and look for other vacuum leaks that I'm not aware of yet. But in general, today was a good start. Took a lot of time behind the scenes to get this thing ready up on the engine stand. You guys know I borrowed some components off this engine to make Benji's engine run, like an injector and some other devices, some of the wiring and stuff. So it's all been put back. Everything is up and running. And now it just needs like a nice little makeover, ready to go into Mac. So thanks again for watching. Huge shout out to FTech9, because that diagnostic software is fantastic. I was able to locate the problem pretty quickly, and also working on the engine test stand makes working on these engines actually pretty fun. So that's a shout out to Zalix Industries, which happens to be myself. So really happy here, guys. See you next week. Cheers.